Okay, so anyway, finding a derivative of a constant. You think about the derivative, and most people, once they start derivative rules, they don't necessarily think of the function itself. They just try to memorize the rule. But if you remember the reason that the derivative of a constant is 0, then you'll remember it. And instead of just memorizing the rule, understanding that the derivative is the slope of the tangent line. And if you look at the graph of a constant, y equals some constant, it's just a horizontal line. And so any horizontal line has a slope of 0, and therefore the slope of a constant is 0, and therefore the derivative is 0. So there you go. So the derivative of any constant, no matter what the constant is equal to 0. And so we're going to get into more functions other than just um, the f of x. And I'm pausing here, sorry. Pausing here because I was wanting to give you guys the different notations for derivatives. And so let me do that now actually before we get started. At the very top, we've got y prime. So all these different notations for derivatives. Y prime, we already talked about f prime of x. So y prime is the derivative of y, and f prime of x is the derivative of f of x. We also can write d dx, and we can write df of x dx, or dy dx. Any of these are also derivatives. We can also have a capital Y, capital D, dy dx. Any of these notations are notations that we use in sometimes different contexts to define what the derivative is. Okay, or to identify, I should say, what the derivative is. So you get used to these. They become just kind of something that you talk about, see all the time, and typically it's not that big of a deal after a while. But I know at first, new notation is kind of hard to get used to. But anyway, if we talk about the function y equals 7, then y prime equals, because y is a constant, y prime equals 0. If we talk about f of x being 0, then f prime of x is also 0. So once you get to 0, all successive derivatives are also going to be 0. And again, we don't have to limit our discussion about derivatives to functions of x. We can have s as a function of t. If s as a function of t is equal to -8, which is a constant, then s prime of t is equal to 0. And then again, as I said above, that dy dx indicates a derivative. Well, y equals a times pi cubed, and a being a constant, pi being also a constant, being raised to the third power. Well, dy dx is equal to 0. So not a big stretch here. Every single one of those problems here in this section, the derivative is 0, because all of those are constants. Okay. And then the next rule, we don't normally talk about this because once we get to the power rule, it covers the single variable rule. But the single variable rule is just that. If it's a single variable, in other words, y equals x, if it's y equals x, then the derivative is 1. And if you think about that, again, if you understand why the derivative is 1, understand that y equals x is a diagonal line, and the slope of that line is 1, so therefore the derivative of x is equal to 1. Okay? And again, y equals x, y prime is 1, f prime of x is 1, and if s of t is t, then s prime of t is 1. Well, let's generalize that. And we talked the other day about, we took functions and we tried to find the derivatives on the calculator, and I can't remember which class period we focused on x squared, then x cubed, and x to the fourth. I think that was 6th period, so maybe first and second period didn't get that. But we found that the derivative of x squared was 2x, and the derivative of x cubed was 3x squared. So if we look at that, derivative of x squared with respect to x is 2x, and that's right here, y prime equals 2x. We'll get to this in a second. We did find out that that the derivative of x cubed was equal to 3x squared. And from just doing these two derivatives, you might notice a pattern, in which the exponent is right out here. Yeah, the exponent is right out here, and then maybe, alright, subtracting 1 from the exponent. But that's exactly what this is all about. The power rule, I should have highlighted that like I highlighted the other one. So the power rule says that the derivative of x to a power is equal to, you take the power out in front. Oh, I kind of messed that up. And then you multiply by x, but then you just subtract 1 from the power and you have your new derivative. Okay? So just like we did over here, y prime is equal to 2x to the first power, which is just 2x. F prime, then, of x, if f of x is x to the 6th, then f prime of x is equal to, you take the 6 and you bring it out in front, multiply by x to the 6 minus 1, or 5. And that's it. S prime of t is equal to 30 times t to the 29th power. So again, s of t is t to the 30th. S prime of t, the derivative of s of t, is equal to 30 times t to the 29th. And it's usually, sorry, I didn't even show you that. It's usually about this point when students are saying, well, why didn't you tell us this in the beginning? This is so much easier. And it is. It is much easier. But you do have to understand why the derivative is what it is, and you also have to be able to recognize the definition of the derivative, because that'll come up in certain applications. And if you ever decide you're going to become a math teacher, I don't know why you wouldn't. But anyway, if you ever decide to do that, there's a test you have to take, and you have to prove everything. And a lot of the proofs start with finding the definition of, using the definition of the derivative to prove that some of the derivative rules. And so that is probably in most of your futures, because I don't know why you wouldn't want to be a math teacher. Anyway, y equals radical x, which is equal to x to the 1/2. So we're going to rewrite it so that x is raised to a power, which makes it much easier to see it for me. Y prime then is equal to 1/2 multiplied by x to the 1/2 minus 1, which is equal to 1/2 times x to the negative 1/2. And normally we're going to write that as 1 over 2 radical x. Okay, so yeah, you do get a little flexibility here. You do not have to rationalize the denominator. You can just leave it like that. You could leave it just like this as well. That's okay. I'm going to go ahead and have you guys do these next couple here. I'm going to do E and F. So why don't you go ahead and do E and F. And pause the video, and I'm going to go ahead and do them. Okay, y equals x to the negative 1. So y prime is negative x to the negative 2. I'm just going to leave it like that. We could simplify if we wanted to. Okay, f is f prime of x. F is x to the negative 3, so f prime of x is equal to negative 3 times x to the negative 4. Okay, well, that's all fine and dandy. Let's go ahead and take a look at the next section. It's called the constant multiple rule. And the constant multiple rule just says that if we have a differentiable function, c is a real number, you just bring the c out in front. Okay. The derivative of c times the function means you can just bring the c right out front. That's all. Okay, well, what does that mean? Well, let's take a look at a couple of these problems here. Let's rewrite 2 over x squared as 2 times x to the negative 2. You can do this. You can simplify whatever you're taking the derivative of. And simplifying it really just makes it easier to see and makes it easier to use the power rule. So anytime you're able to use the power rule, it's a really helpful tool just to rewrite the expressions so that you can easily find the derivative. So what this says, this constant multiple rule says, basically if there's this constant out in front, then that just kind of goes along for the ride. You're going to take the negative 2, you're going to still bring it out in front, but now since there's that 2 there, we're going to go ahead and multiply the 2 times the negative 2, and we're going to get negative 4. We're still going to subtract 1 from the exponent though, so we get negative 4 times x to the negative 3, and if you really don't like that negative exponent, then we can just write it as negative 4 over x cubed. Okay? And so, same thing over here. In fact, I would encourage you to go ahead and pause the video if it seems like, oh, alright, this is pretty easy. Then yeah, pause the video, and I'm going to do the next couple problems. So f prime of x here is 4/3. Okay, 4/3 goes along for the right, and we're going to multiply that by 3x squared, and the 3's are going to cancel. We're going to get 4x squared. Okay, over here, s prime of t is equal to negative, and then 5t to the fourth, and then we don't have to do anything else to that. It just stays right there. Okay, I encourage you to pause the video. I'm going to do the next couple. In fact, I'm going to do D, and let's go ahead and go to G and H. Let's go to the hardest two of this section. Okay, so pause the video and try these on your own. We get rewrite this expression as 4x to the 1/2, so therefore y prime is equal to 4. Now we're going to multiply it by the derivative of x to the 1/2. And the derivative of x to the 1/2 is 1/2 times x to the negative 1/2, right? 1/2, bring the exponent out front, multiplied by x to the 1/2 minus 1, which is negative 1/2. Okay, and then that cancels here. The 4 cancels with the 2, and we get 2, and we can write that over as 2 over radical x. Okay, 2 over x to the 1/2, 2 over radical x. And then g, we're going to write this as 4 times t to the negative 1/2. Sorry, I almost put it as negative 2, negative 1/2. And so therefore s prime of t would be equal to 4 times, and then we have the negative 1/2 multiplied by t to the negative 1/2 minus 1, which is negative 3/2. And I'm just going to leave that alone, leave the exponent alone, t to the negative 3/2. We don't have to rationalize, we don't have to simplify too much. Okay. If you're good with roots, then this should not be a big deal. Remember, roots go on the ground, and this third root would be underneath, so we have this x to the negative, and then where does the 3 go? Well, the roots grow under the ground, and that means it's in the denominator. So we have negative 12 times x to the negative 5/3. Therefore, y prime, you didn't see that, y prime equals that negative 12, and we're going to multiply by negative 5/3 times x to the negative 5/3 minus 1. Now, that's a lot to do in my head, so minus 1. And I could leave it like that, but that would be kind of lame. Let's go ahead and multiply the negative 12 times the negative 5/3. It's going to give us positive 3 goes into 12 4 times, so positive 20 times x to the negative 5/3 minus 3/3, which would be negative 8 over 3. Okay? And there you go. So that's the first video, first page, and I'm going to start a new video here and tackle that second page. So hopefully this is something that's starting to make a lot of sense to you, and I'll see you in the next video.